According to my watch, it's now the appointed time for the webinar. So welcome everybody to today's webinar, which is on the importance of functional safety assessments. So just a little bit of housekeeping to start with. Normally, those of you that have attended exida webinars before know that you can register questions as we go through, and then I'll review and answer at the end. So if you do have questions, please use the question box to register any questions. So the topic for today, functional safety assessments, is following on from a blog I did regarding the importance of them. And part of the reason for doing the blog, and hence the webinar, is because I've been having discussions with companies where it's become very clear that a lot of people are not too sure, number one, what a functional safety assessment is compared to an audit, and number two, what are the benefits of doing that? So hopefully this will give you more. Those of you that are new to exida and haven't been on any of our webinars before, I will just go through this briefly. Those of you that have attended many webinars, just bear with me for a couple of minutes while I just give an overview. So exida has been in business now for over 20 years. It was originally started by two gentlemen, and the purpose was to assist manufacturers with coming to grips with what was then the new standard, IEC 61508 for functional safety for products, and to help manufacturers understand what's required to have certified devices. Since then, the company has grown exponentially, and we don't just do certification for products for safety. We also now do certification of products for cybersecurity to the 62443 standard, and we also do certification of personnel. Some of you may have undertaken doing CFSE or CFSP, the Certified Functional Safety Professional or the Certified Functional Safety Expert. And now we have the equivalent in cyber, the Controls Automation Cybersecurity Specialist and Expert. Furthermore, we also offer full lifecycle services for supporting functional safety, cybersecurity, and of course, alarm management. These three are very tightly coupled together when it comes to overall process safety. And so therefore, we have worked with many customers to help them in this area. Finally, the third piece of the jigsaw is the tools, the software tools that we have that support the services and the certification that we do. Some of you may be very familiar with the Excellencia tool, some of you may not be. And we are global. We have offices all around the world. The last office we opened was in Ireland just before COVID. And as you can see, we are well spaced geographically. We are always looking at expanding and growing, and so there will obviously be more offices as time goes on. The nice thing about what we do is it's industry agnostic, so you can apply it to any industry where safety is an issue, functional safety is an issue, the alarms and cyber. So we work in the steel, the chemicals, mining, and now, of course, the automotive. We do a lot of automotive safety, and robotics is now another area. Machinery and robotics, very important. So we're constantly looking at how we can apply these requirements in different areas, different businesses. From our point of view, we are no longer just owned by the two guys. It's migrated to be more employee owned, and that's intentional, so that effectively we all have skin in the game. We are the leader when it comes to doing certification globally, and we now have well over 100 consultants, done over 1,000 assessments, and modeled more than 500,000 CIFs using the Excellencia tool. We do have a lot of reference materials. I always encourage the classes I teach to utilize the exida.com webpage, because what you'll find there are these webinars, for example, are all recorded and made available through the website, but also you can access the papers that we've written. We also have our safe automation equipment list if you're looking for certified devices, and the books that we publish to help. Just a bit about me. I'm not going to go into too much detail. Some of you know me, some of you don't. I've been around in industry since 1977. My background is mostly in controls, automation, and safety and cybersecurity. And I'm also, apart from being heading up the services business, I also am one of the primary instructors on the functional safety, as well as teaching on the cybersecurity as well. So that's it for the introduction. Let's get to the meat. So, the importance of conducting a functional safety assessment. As I said to start with, a lot of people are not sure what a functional safety assessment is or what benefits does it give them. And the reason why functional safety assessments are required and are important is because functional safety overall, for safety instrumented systems and the related instrumentation used within the safety instrumented functions, is governed under a life cycle approach. The IEC 61511 and even the IEC 61508 both follow a life cycle. The life cycles have three phases. They have an analysis phase, they have a design and implementation, and an operation and maintenance. And the whole purpose is to maintain the level of risk reduction. So these standards are performance-based standards, and the difference is that a performance-based standard will identify what you need to do, but it won't tell you how to do it. It leaves that up to you, so you can utilize the up-to-date technology and techniques. Whereas with a prescriptive standard, some of the old standards, for example, they told you what you needed to do and how you had to do it. There was no leeway, there was no ability to utilize different techniques. So when it comes to the safety life cycle and performing these relevant phases and the tasks within those phases, we govern it, we manage it by using functional safety management. And part of functional safety management means that we have to do these regular functional safety assessments. I always like to simplify things, and typically I characterize functional safety management as being the glue that holds it all together. Because if we don't follow the safety life cycle, and remember, this is applied to the safety instrumented systems and any independent protection layers, then we will very quickly become unstuck. And functional safety management is all about helping us to manage the risk of introducing either random or, in particular, systematic faults into the safety instrumented system design as we go through the life cycle. And systematic is typically characterized by what we call the 3 Ps. The first one is people. If we don't have properly trained and competent people, then we can very easily make mistakes, introduce faults, and so on. Procedures, if we don't have written procedures that are being followed, this is another area. And of course, the final P is paperwork. Do we have a documentation trail to prove we're doing what we said we were going to do? So the purpose of the functional safety assessment is to help us by providing a means of doing an independent, and here's the key word, independent check on safety. So it's not a biased view. And that's why if the team that's doing the engineering should not be doing the functional safety assessment. Because what we're trying to do is we're trying to help spot and identify systematic failures early enough so they can be addressed. Now, some of you may be very familiar with the HSE, the Health and Safety Executive in the UK, their famous pie chart that was the result of the studies they performed in 2003 and also previously in 1995. And what they did is they looked at the causes involving control systems and safety systems. And what they found was that 44% was due to a bad specification or a poor specification. And then, of course, if the specification's bad, well, then you can't expect the design and implementation to be much better. So you can see that just with the specification and the design and implementation, that's the majority of where these faults can be introduced. But also at the back end, after commission's been done, during operation and maintenance, and even installation and commissioning itself. So these are all systematic type problems that were introduced. So what is the definition of the random versus systematic failure? A practical definition of a random failure is a failure due to a non-deterministic system component, loss of functionality, typically hardware related. Now, the reason we say typically is because a lot of times people think that any human error is automatically systematic, but that's not necessarily true because we can be well trained, we can be competent, but we just make a mistake. So those would be random. So for a systematic practical definition is a failure with a deterministic cause, which could be a bad requirement specification. And as you saw from the HSE study, 44%, a design fault, wrong component selected due to either poor knowledge, read competency, error in the software program, etc., when caused by this incorrect knowledge, lack of competency, or incorrect process. So these are the ones that we want to avoid because they're insidious and they can only be corrected by changing something. So if we look at the life cycle, there is the functional safety management with the functional safety assessments. And now the standard, the 1511 standard, defines 5 functional safety assessments. Now the first one, the FSA 1, should be done at the end of the analysis phase. Now going back to that HSE pie chart, 44% was due to bad design. So why would we not want to make sure that at the end of the analysis phase, where we've gone through and done our hazard and risk assessment, we've done our layer of protection analysis, we've identified what our safety instrumented functions are and what the SIL requirements are, assuming we need safety instrumented system with safety instrumented functions, and then creating the initial safety requirement specification. So this is critical. If we've made a mistake, or if we haven't performed the HAZOP properly, if we haven't identified all the hazards, if we haven't defined what the safety instrumented functions are and also what the integrity requirements are correctly, we could end up with either an expensive over-design because we've got too many SIFs or the SIFs have their risk reduction is too high, or conversely, which is worse, too few. So we have a dangerous under-design. Oftentimes when we do SIL verification, we always look for the hazard and risk assessment report and the layer protection analysis, if it was done, to make sure that it's all correct, but we often find problems. So FSA 1, why would we not do that? The second one needs to be done at the end of the initial design phase when we've doing the factory acceptance test. So this is where we bring the logic solver together with the application and we make sure that the application and the logic for the SIFs is correct as far as we can go at that point. So this would be a stage 1 of the overall validation. The FSA 3 is the mandatory one we have to do before we start up. So this one is where we would look at, do we have everything we need? Does the as designed safety instrumented system with its safety instrumented functions, meet all the requirements of the SRS. So once it's been designed, installed, configured, commissioned, then we do the overall validation. And very often, this is the first one that people do. And to me, that's a bit silly, really, because by the time you get to this point, you're getting ready to start up. If you fail an FSA 3, then you shouldn't really start up. Of course, that's down to the end user to decide whether to do that or not, but they have to recognize the risk they would be taking in doing so. Plus, the other thing to check is if you're not self-insured, the insurance company might have something to say. And then the next one that we have to do is the FSA 4. Because this is a performance-based standard, we have to have a means of measuring our performance. So we should have some key performance indicators that we can pull and measure. So the standard says we need to do this after a period of time. It doesn't tell us how often or how long we have to run before we do it, because it's a performance-based standard. It says you need to do it, doesn't tell you how often you need to do it. That's down to the end user. And then the FSA 5 is when we need to make any changes. So these 5 are very important. And remember, the purpose of performing a functional safety assessment is to provide us with this independent, there's the key word, an independent and diverse cross-check of safety to identify and correct potential systematic failures. That's the whole purpose of doing this. Then, of course, we want to make sure that the safety instrumented system meets the SRS and actually achieves functional safety. Does it actually achieve what we set out to design? And here again, it can be an independent team within the company, as long as they're competent, or it could be one competent senior person who's not involved in the design as a minimum. You can, of course, use third parties as long as they're qualified to do it, because the independence is not an issue. And of course, we have to perform at least 2 of them. Now, the way the standard is worded, it's a little confusing because it says whichever FSA you do, you need to make sure that any previous FSA recommendations have been implemented or at least resolved. So if you didn't do the previous FSAs, how can you do that? And I know that there's a change coming in 1511 and probably will end up with these being made, or more of them being made, mandatory. So the independence is the key thing. And therefore, what we would need to do is define an assessment procedure that's appropriate for the SIL and, of course, the complexity of the design. Now, with a higher SIL requirement, there will be potentially more rigor required. And also, there could be more complexity in the design. So we appoint an experienced team or team of reviewers that are qualified and competent, define the scope of the assessment, create a plan for the reviewing, and also what we expect to achieve. The key is, obviously, if we do get discrepancies, what do we do about that? That's important. If there are any relevant safety bodies or certifications that have to be addressed, and then, of course, you conduct the assessment. So the whole purpose is, do we really have what we need up to the point that we do this assessment? So some of the key items, of course, as I mentioned already, the FSA 1 would be looking at the hazard and risk assessment that was done. It will be looking at did we identify correctly all the hazard scenarios? Has it been documented? What technique was used? Was it a valid technique? And these are the techniques that are approved, if you like, under 1511. Did we do a layer protection analysis? Has the SIL targeting been done correctly, and so forth? Then does the safety requirement specification include all the relevant information up to this point? So for an FSA 1, it would include all the process information. It would include the list of the safety instrumented functions and their SIL targets, the performance levels. There might be a target for the spurious trip, the mean time to fail safe, and so on. There won't be the design information, of course, because we haven't done any design. That comes next. Then we go into doing the the actual design of the CIFs. We would do the verification, the SIL verification. Any equipment acceptance tests would be documented. The choice of equipment, is it suitable for the environment? Do we know? Is it for severe service? I mean, we've had a client that had problems with their valves because they were failing within the first 6 to 8 weeks due to the fact that they hadn't been properly chosen for the application. It was actually severe service. It wasn't clean service, and the valves were designed for clean service. So these things need to be checked and made sure. And so doing these FSAs, you would be able to spot certain things that you could correct. Operation testing and maintenance procedures. Before we do our startup, we have to make sure those are in place. And also, if we have any training requirements for if it's new equipment, the operators need to be trained. Validation that equipment actually meets the SRS, of course, and then the operational evidence of performance, which is our FSA 4. So let's look at FSA 1 in a little more detail. As I mentioned, the process we go through is the hazard and risk assessments that are done. That means that we need to have properly qualified all the hazards. We've gone through the analysis. We've identified if we need additional risk reduction through our layer protection analysis, and then if that risk reduction has to be in the form of a safety instrumented function, and if so, what amount of risk reduction does it need to achieve, which is defined by the SIL target. So have we captured all of that properly, and is it documented in the SRS? So the FSA 1 would make sure that do we have what we need at this point, doing this independent cross-check. And of course, if we find issues and problems, we can address them before we move on. That's the whole purpose. Because as you can imagine, the further down the life cycle we go, the more expensive it becomes to correct and fix problems. For the FSA 2 now, this is where we've done our detailed design, we've selected the technology, we've done the SIL verification, we have the equipment justification report, and we should be generating the detailed hardware and software safety requirements. So all of that should be complete. We should be updating our SRS to include this design information and making sure that the documentation is complete. Then the factory acceptance test is the first opportunity to integrate the logic solver with the application and do black box testing to make sure that the CIF logic performs the way it should, and as much as we can do to test the timing up to this point. We could also use this as an opportunity to do some cybersecurity testing, test the communication robustness, test the hardening of the devices. So there's some penetration testing we could do whilst it's on the shop floor. And also as part of this, we could do our FSA 2 and witness the testing and make sure that everything up to this point is there. We don't have any gaps. We don't have any potential systematic issues. So this would be the FSA 2, and this is before it goes to site. And then once it's been shipped to site, it's been installed, it's been commissioned, we do the final validation. So the final validation is, of course, to make sure that our as designed, installed, and commissioned safety instrumented system and its safety instrumented functions meet all the requirements of the SRS. So we have a complete SRS. The commissioning report has been completed. We would also perform a cybersecurity audit because, of course, now having gone through the commissioning, we have to make sure that our barrier devices are properly configured, firewall rules are set up correctly. If we're using switches for the communications, have we properly hardened them? Have we switched off unused ports and so on? Because during commissioning, changes can occur and they should be following management of change, but we may have introduced a potential vulnerability. This is why it's a good idea to do the cybersecurity audit at this point prior to startup as part of our PSSR. So as I said before, a lot of times companies, if they do an FSA, it's usually this one. But what happens if this fails? If we find a problem, if we find something that is not complete, then what? Well, of course, what we have to do is we have to do an analysis, figure out where we have to return to in the life cycle, and then do the corrective action, go through the validation again and make sure everything is okay. So this can, as I said, if the FSA 3 does not pass, then we should not start up. And if we do start up, as I said, that's just adding risk, because statistically most accidents have occurred during startup or commissioning. Or maintenance. So we would have to go back to the appropriate phase, which could be we have to go all the way back to revisit the hazard and risk assessment. It can be potentially very costly. It also results in delays, which could translate into penalties depending upon the contract. So can you really afford this? And this is why when I teach the class, I always say these FSAs are there for a reason. They're there to help us find potential systematic issues before we go too far and before they become a real problem. So why not do them? So we would have to obviously do the analysis if we found problems. I mentioned this already. If the end user chooses to start up, then there should be proper consultation to make sure that the risk is going to be mitigated. Especially if you're not self-insured, you need to talk to the insurance company because they may not support starting up. And of course, if you do and there are consequences, these can be extreme. Now the FSA 4, this is another one where I talk to clients about, and very few are doing FSA 4 or have done an FSA 4. Remember, this was mandated in the 2016 edition, so that's 6 years now. In some parts of the world, it's a requirement to do FSA 4. So the whole purpose of the FSA 4 is this operational evidence of performance. So for example, how do we know if we're not measuring our performance, whether we're overachieving, whether we're meeting requirement, or whether we're underachieving and not meeting requirement? So again, some of the KPIs that could be used as performance measurements could be the proof test interval. Are we doing the proof testing according to the SRS? The repair and restore times. If we have to repair and restore equipment, are we meeting the mean time to restore specified in the SRS? Spurious trips. Are we meeting the spurious trip requirement? Equipment failures. If we're getting a lot more equipment failures than we originally intended, we need to investigate as to why. There could be a potential underlying systematic issue. Also, any trips, if they were real or otherwise, they need to be recorded. And of course, the failures themselves. And what type of failure was it? Which failures should be investigated to root cause analysis to see if there is an underlying potential systematic issue that needs to be addressed. And the purpose is that we can use this data. And obviously, after we've been running for a period of time, we can use this data. We can use it to feed into the revalidation of the hazard and risk assessments that have to be done every 5 years, to make sure and check and see if our assumptions on the demand rates, on the hazard frequencies, etc., were correct. And again, the purpose of the life cycle is it helps us to balance out our design with our requirements. If we're finding that our performance is much better, then this gives us the opportunity to start looking at, okay, can we extend our proof test intervals further out? That will obviously alleviate some of the maintenance burden, so it can save some money. But these decisions can be made based upon real data. As long as we're collecting the data properly, we should be able to use that. That's why it's so important to do an FSA 4. The standard also requires, and again it uses the word periodic assessments of our operations and maintenance people. So we can use the FSA 4 as again another trigger point to make sure, okay, are we maintaining the standard of competency of our operators if we've had some turnover of staff or changes in personnel moving into different functions? Those people coming in, are they also maintaining their level of competence? And competency records would be looked at as part of an FSA 4. So the FSA 5, of course, this one is regarding management of change. So before any changes is implemented, we need to assess the impact, the potential impact on safety. And this, of course, needs to be done by somebody who's competent, senior and competent and responsible to undertake this work. And then if the change is approved, we need to decide where in the safety life cycle we have to go. And of course, does it have an impact on the SRS, and does the SRS has to be updated? Remember, the SRS is a living document and it needs to follow the safety instrumented system and its safety instrumented functions from inception all the way through to operational. So the operations and maintenance guys have to have access to the SRS. They need to know what's in it. They need to know what the SIFs are doing, of course. And therefore, if we're going to make any changes, we have to evaluate changes against the SRS. So this should also be done, but it isn't always done to this extent. And then finally, at end of life, we will decommission. So how can we do good FSAs? Checklists is a good way to start to make sure that we cover all the bases for the particular FSA we're doing. You can use templates. We at Exida have templates for all the FSAs. This means then you're being consistent, you're not missing anything, and it's repeatable. You can use independent third parties if you so wish. The clear advantage of that is the independence is not an issue. The only thing is you need to use qualified independent third parties to undertake the functional safety assessment, or you can use senior competent people within the company that are not involved in specifically in the SIS design, and they can undertake the tasks. The use of tools helps with documenting the process, of course, and gives us this consistency and can save time. Documentation, we should also ensure that all the documents are readily available before we carry out the FSA. It just, again, keeps it efficient, saves time, and then make sure that the latest versions are being reviewed as part of the FSA. From the training aspect, we need to make sure the people are properly trained and that we have tracked the competency and we're doing these regular assessments. Templates and checklists, as I've said, if you're an Excellencia user, you'll find that there are templates. There's a 615.11 template in there, which helps you with the specific clauses of the standard and the requirements and helps with some of the compliance. So these can be completed with the corresponding project information to support that functional safety management and assessment process. All right, so let's finalize this. Functional safety assessments, as we've seen, is a necessary part of overall functional safety, safety management, and the whole purpose is to help us minimize the potential for introducing these nasty systematics, which we know can cause us major problems. Currently, and this will probably change, that's not required that you do all 5, but when I teach the class, I always highly recommend that these be done because they're there for a reason. They're there to help us. They help us safeguard against the potential for these systematics creeping in. You don't really want to wait until FSA 3 to do your first functional safety assessment, because, as I've said, if it fails, then you won't be able to start up, and of course the delays can be lengthy and costly. And remember, insurance companies are becoming much more aware of this now, and they may take a dim view if you fail, then you try and start up. So beware of that. If we do these FSAs properly, they can potentially help us to avoid costly rework. As I said to you, the further along down the life cycle you go, the more expensive and time-consuming it can be. If you perform the FSA 4s, that helps you monitor performance and prove that you're tracking according to the original design intent. You can use tools and checklists as long as they're applicable, of course, and you need to have competent and well-trained personnel involved in doing these. You can use independent third parties as long as they're qualified to conduct the functional safety assessments. And some companies, when they do FSAs, they take that approach because it's easy to prove the independence. So if you want to know more, of course, keep up with us on our usual social media and other webinars that we're doing. I have done a series of Exida Explains. We're now doing these vlogs, if you like, video blogs. And also, we will be doing more webinars throughout the rest of this year. If you have any particular questions that we don't cover now, then by all means, feel free to drop me an email. So let's see, what questions do we have? All right, so could we find a guidance to practice FSAs? Well, the standard gives you some guidance on that. Of course, we can help with that. We have, as part of our functional safety course, is some training on this. So those are sources you could use. If you want, you can purchase the templates through our website and do it yourself, or do it with our support. So those are some of the things you can do. All right, for existing operating safety instrumented systems, when a change takes place that impacts the functional safety and the MOC process has been carried out, shall we conduct a new FSA due to this change? Well, in theory, you should be doing the FSA before you do the change, because part of the FSA 5 is to do that safety impact analysis, which needs to be done before you do the change. Once you've carried out the change, then you should perform a proof test, or you should verify that the change has been implemented correctly. Are there limits to how much the PHA should be reviewed by an FSA 1, by FSA team? Well, again, it depends upon the amount of, how many nodes have you done, how many hazard scenarios have been captured. So typically, as I said, for an FSA 1, there is guidance on what needs to be looked at. It will be down to and this is what I said beforehand, is that you define a process and a procedure. How are you going to conduct this FSA? What's the scope? And again, depending on which one it is, if it's number 1, then it's obviously going to be looking specifically at the hazard and risk assessment and how the SIFs were identified and the SILs determined. So I wouldn't say there are limits on how much. It's a question of how many hazard scenarios have been defined, and how good is the documentation, and how good is the way it was conducted, and so forth. Interesting one. I've not heard that one before. Must the FSA and the cybersecurity safety assessment to match in time? I'm not sure I understand the meaning of the. I think what you're asking me is if the cybersecurity assessment needs to be done as part of that FSA 2, I think. Again, if I've misunderstood the question, please email me. I mean, typically, the standard is very clear. Clause 8.2.4 says that we need to conduct a cybersecurity risk assessment, and the guidance steers you towards using 62443 and TR 8409. But part of the FSA could be that certainly the FSA 3 will be looking to see, did we perform this? And you could even do it at FSA 2, as I said, if the SIS, if you have it on the shop floor, you're doing the factory acceptance test, that's a good place to do the risk assessment at the same time. But it doesn't necessarily have to be done at the same time. We would at some point have to cover it. And in fact, the TR 8409 sort of suggests you follow the same approach for safety as you do, the same approach for cyber as you do for safety, which is that you have a cybersecurity assessment. And you do a cybersecurity assessment 1, 2, 3, 4, and 5. Oops, where's the next one? How does performance evaluation interact with FSA 5? Well, again, the performance evaluation, I'm not sure, again, if you're talking about FSA 4, if FSA 4 is not, it doesn't occur because of a change. The FSA 5 is specifically targeting any potential changes that are looking to be made to the safety instrumented system. So again, I'm not sure if I've seen what you're trying to get at there, but again, send me a note and I'll have a look. Have you any advice on verifying competence of operations and maintenance personnel? Well, there's a number of ways you can do it. Again, because it's a performance-based standard, it says you need to do it. It doesn't tell you how to do it. So you could do it by having a senior guy observe how an operator's working. Sometimes a lot of the DCS people will provide you with simulators, so you can effectively have the same application running on a simulator, and then there's an instructor's console and there's the operator console, and the instructor can go in and upset the process or throw in curveballs and see how the operator deals with that. That's another method. Or you could do some form of written exam or some form of online testing. There's a number of ways you can do it. It's just, and this is why the standard doesn't define how you can do it. We've been working with clients to help them with training, certainly, to do that. Let's see, what else do we have? Follow up on PHA question, where hazard scenarios do not use instrumented risk reduction. Is that in scope of the FSA 1? We exclude not SIS related scenarios, for example. Yeah, I mean, that's an interesting one because, yes, as we go through doing the hazard and risk assessment, if we determine that we can achieve the tolerable risk without the addition of a safety instrumented system using normal independent protection layers, we should still make sure that we have covered that properly. Because if we did the risk assessment incorrectly, or if the tolerable risk wasn't defined properly, we might be understating again the amount of risk reduction we need, which could push you into using a safety instrumented system. So I would suggest that it would be beneficial even if it's a fairly simplified functional safety assessment, it still should be done because you're still relying on IPLs to meet your risk reduction requirements. All right, follow-up performance evaluation in FSA 4. Okay, will you be publishing a white paper on the topic of FSAs? That's a good question. I have been thinking about it. Probably we will. Again, it's as with all these things, it's just time. But yeah, we'll probably come up with a white paper on this. Do you have suggestions to get the FSA prep and execute included in the project budget and schedule? Yeah, I know. This is always a good one. Well, the only way I can say this is that, for example, the standard now requires any company, whether it's end user or whether it's a supplier, which means engineering companies, value-added resellers, etc. If you're offering a product or service that's safety related or going to be performing elements of the safety life cycle, then you have to have a functional safety management system in place and you have to prove you're following it. Part of that means you need a functional safety management plan. The functional safety management plan is to define how you're going to achieve functional safety. And of course, that's going to include performing functional safety assessments. So the answer to this is, if you need to be compliant with 61511, then you've got to include it. And this has to be recognized. Now, I understand the challenge with that. It's part of the reason I wrote my book, Functional Safety for Managers, what managers need to know, because oftentimes when I talk to engineering companies, they don't have a functional safety management system in place. They don't have a functional safety management plan for the project that they're implementing. So here again, it needs to be included. And that's going to always be an interesting one when it comes to discussing with management. The way to sell it, because somebody said to me, well, how do I convince management? Well, the point is they're there to help us find potential systematic issues. If we don't do them, we could end up running the risk of introducing a problem that will come back to bite us later on. And of course, dear old Trevor Kletz, who's no longer with us, his famous saying was, if you think safety is expensive, try an accident. And you've only got to look at the cost of some of the accidents. I mean, I think the latest estimate for the Deepwater Horizon, the Macondo, which is still going on more than 10 years later, I think is a roughly 62 billion, somewhere around there, for one accident. So, like I said, I have this conversation, especially when I get, well, we've never done this before, we've never had a problem before, why do I need to worry about it now? And my usual reply is, for every second of every minute of every hour of every day of every week of every month of every year, your risk is going up and up and up. And one day, you may run out of luck. All right, what are some of your most common findings from FSAs? Well, in the ones that we've done, usually incomplete documentation. I also got asked to do an FSA 3 by a company that had already been running for over 18 months. It's a bit like, okay, the horse is over there, let's now shut the gate. Yeah, it's typically things like that, maybe not performing the hazard and risk assessment properly. Now, it was up until about a year or two ago that we noticed it anyway, that a lot of times people, in terms of facilitating HAZOPs or facilitating the hazard and risk assessments, it was lowest bidder. irregardless of whether that person had the right or company had the right background, experience, etc., lowest bidder. And the problem is when you do that, you end up with potential problems, and this is where we've seen this. We've seen that HAZOPs have not been done properly. For example, the tolerable risk wasn't defined correctly, things like that. So if you don't do these FSAs properly and don't perform them, then you won't find these issues until much further on down the line. All good questions. All very good questions. Any other questions? Did I capture? I think I got every question that popped up. Like I said, if a couple of the questions I didn't really understand what you were getting at, maybe if you'd be kind enough just to drop me an email and help me understand what the meaning is, then I can respond to you better. If there are no other questions, then I thank everybody for their attendance and certainly for the questions that have been put forward. Very much appreciate that. Very much appreciate your attendance. I know it's late in the day for some people, and look out for the next set of webinars that are coming along. If there's a particular topic you think that's worthy of us doing a webinar on, but also let me know. Be happy to accept any suggestions. So with that, I bid you a good rest of your day and thank you for attending. As usual, this webinar is recorded and will be put up for viewing again through our website.